if a sequence of function f of nx converges pointwise to f of x, then it is not always true that we can interchange the integral sign and limit sign. Okay, we cannot always write this way. The dominant convergence theorem and monotone convergence theorem tell us that under some condition we can only do that. So in this video we will learn the dominant convergence theorem, and I will also discuss one example. So the statement of dominant convergence theorem is, if xd is a compact metric space and the sequence of functions f of nx satisfies the following two conditions. First condition is limit of when n approaches infinity, then f of nx is f of x, okay, for all n. And the second condition is absolute value of f of nx is less than or equal to g of x, where g of x is an integrable function, where g of x is an integrable function. Then the conclusion is then the function f of x is integrable, then f of x is integrable and limit of n approaches infinity, integration of f of nx dx can be written as integration over r limit of n approaches infinity f of nx dx, which equals to integration over r f of x dx. Okay, so this part converges to f of x. Okay, f of x. This part converges to f of x. So let's discuss one example to clarify that. Suppose we want to evaluate example limit of n approaches infinity, integration over r sine of x over n divided by x square plus 1 times n x, sorry, it would be x here, dx. Suppose we want to evaluate this integral, and here we will use the dominant convergence theorem. But to use the dominant convergence theorem, first we need to check whether this one satisfies the condition of dominant convergence theorem. So solution, let f of nx is this part. So suppose this part is f of nx, sorry, not integral. This part is f of nx n times sine x over n over x times 1 over x square. Suppose this is f of nx. Now what we need to do? We need to check those two conditions. So the first condition is limit of n approaches infinity, f of nx equals to limit of n approaches infinity n sine x over n divided by x times 1 over x square. Okay, so now it can be written as limit of n approaches infinity sine x over n over x over n times 1 over 1 plus x square. Now from the properties of limit we know that this is equals to 1, this equals to 1. So it becomes 1 over 1 plus x square. Suppose this is f of x. So this would be f of x. Now we need to check the second condition. So to check the second condition, we need to take absolute value of f of nx. So if we take absolute value of f of nx, it becomes, second condition, absolute value of f of nx, it becomes absolute value of n times sine x over n over x times 1 plus x square. Now it can be rewrite as absolute value of sine x over n over x over n times 1 over 1 plus x square. I write this 1 over 1 plus x square outside of the absolute value because for any values of x this is always positive. Now from the properties of absolute sign we know that absolute value of a over b equals to absolute value of a divided by absolute value of b. So we can write this way. Now from the Taylor series we know that, or sin x less or equals to absolute value of x, we know this one. So it can be rewrite as less or equals to absolute value of x over n divided by absolute value of x over n 1 plus x square. Now this one, that one cancel, so it becomes 1 over 1 plus x square, and this is g of x. So this is integrable function, because if we integrate this one we get tan inverse x, where so here g of x equals to 1 over 1 plus x square is the dominating function. Function. So f of nx satisfies both conditions of dominating convergence theorem. Therefore, we can apply that theorem. So by dominating convergence theorem, by dominating convergence theorem, limit of n approaches infinity, integration of n times sine x over n over x times 1 plus x square dx can be rewritten as integration of limit of n approaches infinity n times sine x over n over x times 1 plus x square dx. Now this part is f of nx and it converges to f of x, and we know it converges to 1 over 1 plus x square dx. So it becomes f of x. This is f of x. This is f of x. Now this is an even function, so we can write 1 over 1 plus x square dx equals to 2 times 0 to infinity 1 over 1 plus x square, and if we integrate this part, it becomes 2 times tan inverse x, and its lower limit is 0, upper limit infinity. And if we plug the value, then tan inverse infinity is pi over 2 minus 0. So if you simplify, it becomes pi. So this is the answer. Thanks for watching.